one is Q1, the other one is Q2. These 2 point charges are placed at a separation of r. So these are point charges, not extended charges. There is a difference between point charge and extended charge. For example, consider this metallic body. Consider this metallic body. If some charge is given to this metallic body, then that charge will be distributed on the surface of the body, on this surface, on outer surface, and in that case this will be considered as an extended charge distribution. This is a metallic body. If some charge is given, that will spread on the surface of the body, and that will be considered as extended charge distribution. In this case we are considering not extended charge distribution but 2 point charges. This is a point charge, this is another point charge, and they are separated by a distance of r. Then, as you know, each charge will exert a force on the other charge. If they are like charges, means having same sign, then they will repel each other. Okay, this is positive, they will repel each other. This is negative, they will repel each other. But if they are unlike charges, that means if one is positive and the other one is negative, then they will attract each other. This is known to you. Okay, let the force exerted by Q1 on Q2 be F21 and force exerted on Q1 by Q2 is F12. So F21 equal to force exerted by Q2 or on Q2 by Q1, and F12 equal to force exerted on Q1 by Q2. These two forces are equal and opposite, because according to Newton's third law, the forces are equal and opposite. Action reaction forces. These two forces are actually action reaction forces, so they are equal and opposite. Hence, by Newton's third law, F21 equal to minus F1. Have you understood this point? That each charge exerts a force on the other charge. These forces are equal and opposite. So by Newton's third law, they are equal and opposite. Okay, let F21 equal to F12, magnitude equal to F. Magnitude of F21 equal to magnitude of F12 equal to F. Then F equal to 1 by 4 pi epsilon into Q1 Q2 by R square. F equal to 1 by 4 pi epsilon into Q1 Q2 by R square. What is epsilon? Epsilon is called the permittivity. Epsilon is the permittivity of the medium in which the charges are placed. Epsilon is the permittivity of the medium in which these two charges are placed. So in bracket you write epsilon equal to permittivity of the medium in which the charges are placed. This is equal to 1 by 4 pi k epsilon naught into Q1 Q2 by R square. Epsilon equal to k into epsilon naught. Now what is epsilon naught? Epsilon naught is the permittivity of free space. Epsilon naught, free space means vacuum. Free space means vacuum. Epsilon naught is the permittivity. Permittivity of free space means permittivity is something which conveys whether the medium will allow the electric force to act or not, to propagate or not. Permittivity of a medium. If the permittivity of the medium is very poor, then electrostatic force exerted by one charge on the other charge will not be able to propagate that effectively. This is the idea of permittivity. For example, vacuum or air, its permittivity is excellent. Excellent permittivity. Okay, so it allows the electrostatic force to easily propagate. Okay, for example, you consider any medium other than vacuum. For example, you consider rubber. Permittivity of rubber is not that good. That means if you place charges in rubber, then the force will be immediately be reduced. Two charges placed in air, the force is greater. When the same charges are placed inside rubber, consider a rubber pad, inside that rubber pad you have placed those two charges at same separation. Okay, immediately the force will be reduced. Electrostatic force will be less. In air, if it is 100 Newton, in that rubber pad it may be 10 Newton. So that means the medium in which the charges are existing has a role to play in deciding about the magnitude of the force. Okay, in deciding about the magnitude of the force, medium has a role to play. Okay, and this contradicts with gravitational force. In the case of gravitation, medium does not have any role to play. In all media, gravitational force has same value. If you place two masses in air, if the force is 10 Newton, when you place the two masses in water, then also it will be 10 Newton. If you place the two masses in rubber, then also it will be 10 Newton. That means gravitational force does not depend on medium. While electrostatic force does depend on medium. And the effect of the medium is represented by K. Effect of the medium is represented by K, where K is called the dielectric constant of the medium. So epsilon naught, right here, epsilon naught equal to permittivity of free space. Permittivity of free space, and K equal to dielectric constant K equal to dielectric constant of the medium. So I am explaining this once again. Epsilon is called the permittivity of the medium, and epsilon equal to, dekhe nao to, check kore nao to, epsilon equal to K into epsilon naught. What is epsilon? Permittivity of medium. What is epsilon naught? Permittivity of free space, means permittivity of vacuum. And what is K? Dielectric constant of the medium. Okay. So what exactly is K? K is actually a number. K is actually a number. Dielectric constant of air is 1. Dielectric constant of paper, you may consider paper as a medium. Dielectric constant of paper is 4. Dielectric constant of mica is 7. Dielectric constant of rubber is 9. Okay, so that means if the charges are placed in a rubber sheet, two charges are placed in a rubber sheet, then if you place them in a rubber pad, then the force will be 1/9. In air, suppose the force is 100 Newton. In air, suppose the force is 100 Newton. Whenever the charges are placed inside rubber, the force will be 100 by 9 Newton. K is 9. If you place these two charges in mica, the force will be 1/7. That means in vacuum or air, the force is maximum. In a medium other than air or vacuum, the force is reduced. Okay. So box this is the main formula. F equal to 1 by 4 pi k epsilon naught Q1 Q2 by R square. Problem. When two charges are placed in air, each charge exerts a force of 1 Newton on the other. Each charge exerts a force of 1 Newton on the other. When the same charges are placed at same separation in a medium, each charge exerts a force of 0.2 Newton. Each charge exerts a force of 0.2 Newton on the other. Find the dielectric constant of the medium. So what is the dielectric constant of the medium? 5. Dielectric constant equal to force in air by force in medium. Force in air is 1 Newton. Force in medium is 0.2 Newton. So K equal to 5. Force in air by force in medium. Okay? 5. Okay. Next question. What is the unit of dielectric constant What is the unit of dielectric constant? Is the dielectric constant of water? What is the unit of dielectric constant? Is the dielectric constant of water very high or very low? All of you have seen that dielectric constant is actually a ratio. Force in air by force in medium. So obviously dielectric constant is a number, it does not have a unit. Okay, dielectric constant of water is very high, it is 80. Okay, so write this. Dielectric constant is a ratio. Dielectric constant is a ratio of two forces. Is a ratio of two forces. Hence, it does not have a unit. It does not have a unit. Dielectric constant of water is 80. Dielectric constant of water is 80. As far as medium is concerned, what is the difference between gravitational force and electrostatic force? As far as medium is concerned, what is the difference between gravitational force and electrostatic force? All of you know the answer? Just write. Gravitational force does not depend. Gravitational force does not depend on the medium. Gravitational force does not depend on the medium in which the masses are placed. In which the masses are placed. Electrostatic force depends on the medium. Electrostatic force depends on the medium that exists between the charges. That exists between the charges. It is maximum when the charges are in vacuum. It is maximum when the charges are in vacuum. In bracket you write K equal to 1. So what is the dielectric constant of vacuum? 1. Okay. Next question. Define the intensity of electric field. Define the intensity of electric field at a point consider a charge Q. You have placed this charge at some point in space. Immediately after its placement, this charge produces something around it which exerts a force on any other charge located in the neighborhood. So in space you have placed a charge Q. This has produced something around it. How do you know that this has produced something around it? Because if you place another in the neighborhood, then you will see that this charge will either be attracted towards this or it will be repelled away from this. That means, what is the conclusion? That means definitely this charge has produced something around it which is exerting force on the second charge. So this something that the first charge produces around it, which exerts a force on any other charge placed in the neighborhood, is called the electric field of this charge. Okay, so that means this is just an interpretation. You have placed a charge in the neighborhood, a force acts on this. A force acts on this. Then we are interpreting. This is an interpretation that definitely this has produced something around it which exerts a force on this. Okay, so this something that this charge has produced around it is called the electric field of this charge. Okay, we will define the strength of this electric field at a point. How do you define the strength of the electric field at a point? You will place a +1 charge, +1, that means unit positive charge. You will place a +1 charge at this point. Okay, the force that acts on this +1 charge is the intensity at this point. Intensity of the field at this point. Okay, so first of all, the concept of electric field. What is the concept of electric field? At some point you have placed a charge. This charge has produced something around it. How do you know that this has produced something around it? Because whenever a second charge is placed in the neighborhood, a force acts. So definitely this has produced something around it which exerts a force on this. This something that the first charge has produced around it is called the electric field of this charge. Okay, so electric field is over. Now we are in the process of measuring the electric field at a point. How strong is the electric field at this point? How strong is the electric field at this point? For that, you will place a +1 charge at the given point. Suppose you are to measure the electric field at this point, here you will place a +1 charge, unit positive charge. The force that this charge will experience is the intensity at this point. Okay, so obviously the intensity at this point will be less compared to the intensity at this point, because if you place +1 charge here, it will experience a greater force. That means intensity is greater here, intensity is less here. Okay, so let us define intensity. Right. Intensity of electric field. Intensity of electric field at a point. Intensity of electric field at a point is defined as the electrostatic force is defined as the electrostatic force exerted on a unit positive charge when placed at that point. On a unit positive charge when placed at that point. Okay. Now, in practice, we do not place +1 charge. Okay. Reason is any amount of charge is not available. Can you get any amount of charge? Any amount of charge you can get? You cannot get. Charge is always in multiple of electrons. Okay, if you want to have 2 into 10 to the power minus 19 Coulomb, you will not get. Charge is always in multiple of electron. Either 1 electron, next higher alternative is 2 electrons. Nothing like 1.5 electron. So minimum charge that you can get is 1.6 into 10 to the minus 19 Coulomb. Next higher that you can get is 3.2 into 10 to the minus 19 Coulomb. Next higher is 4.8 into 10 to the minus 19 Coulomb. Nothing in between. So you cannot get any amount of charge. Charge is always in multiple of electrons. Either 1 electron or 2 electrons or 3 electrons, or absence of 1 electron, absence of 1 electron, 1 positive, absence of 2 electrons, absence of 3 electrons, absence of 4 electrons, like that. Okay, so you cannot get any amount of charge. In practice, what we do, we take a small charge, any amount of small charge, and this small charge is called test charge. This is called test charge, and the test charge should be, you cannot take any amount of charge as a test charge. What should be the quality of a test charge? It should be small, because test charge should not be as big to disturb the main charge. Okay, test charge should not be very big so that it can disturb the main charge. So test charge has to be small. Okay, so this is the test charge Q. You have placed it at the given point. Then you have measured the force. You have measured the force, electrostatic force acting on test charge Q, and this force is F. Then we apply unitary method to get the intensity. In simple unitary method, on Q charge the force is F. On one charge the force is F by Q. By definition, that is the intensity. Okay, so by definition, force on unit positive charge. Then second point is unit positive charge is not available. So what we use in place of unit positive charge? A small charge. What is that small charge called? A test charge. Then we measure the force exerted on the test charge, and by unitary method we find the force exerted on unit positive charge. Okay, so write let the force exerted on a test charge Q, force exerted on a test charge Q be F. Let the force exerted on a test charge Q be F. Then by definition of intensity of field, E equal to F by Q. Okay, force on unit charge. Then this distance is R. So how much is F? F equal to 1 by 4 pi epsilon naught into Q by R square divided by Q into Q by R square divided by Q. Q cancelled. Hence E equal to, this is the complete formula, F by Q equal to 1 by 4 pi epsilon naught into Q by R square. E equal to F by Q equal to 1 by 4 pi epsilon naught into Q by R square. What is the intensity? What is the unit of intensity? Unit of intensity. First of all, from this expression you can easily write unit of F is Newton, unit of Q is Coulomb. So Newton per Coulomb. So unit is Newton per Coulomb. Okay. Next question. K in unless otherwise mentioned, you will always assume that the charges are placed in vacuum or in air. Okay. Otherwise it will be mentioned that the charges are placed in mica sheet like that. When that type of when you will not find that type of mention, you will just assume that the whole thing is happening in air. Okay. Is it clear? So Newton per Coulomb. Next question. Intensity of field is a vector quantity. What is its direction? Intensity of field is a vector quantity. What is its direction? So what is the direction of intensity of field? Will it always be towards this charge, or can it be away from the charge also? It can be towards this charge, it can be away from the charge. Because by intensity we understand force on plus 1 charge. So you have placed a plus 1 charge here. The central charge, suppose the central charge is positive, then it will be repelled. Suppose the central charge is negative, then it will be attracted. So that means force on this unit positive charge can be towards the central charge, or it can be away from the central charge. So that means intensity can have direction towards the central charge, it can have direction away from the central charge, depending on the sign of the central charge. Okay, so write intensity. Intensity is the force on unit positive charge. Intensity is the force on unit positive charge depending on the sign of the central charge. Depending on the sign of the central charge, it could be towards the center or away from the center. It could be towards the center or away from the center. Actually, the direction of intensity is same as the direction of force exerted on plus 1 charge. Actually, the direction of intensity is same as the direction of force exerted on unit positive charge. Okay, so direction of intensity is same as the direction of force on plus 1 charge. If on plus 1 charge the force is in this direction, then intensity is in this direction. If on plus 1 charge the force is in this direction, then intensity is in this direction. Okay, so in this regard, there is a difference between intensity of gravitational field and intensity of electrostatic field. What is the difference? Intensity of gravitational field is always towards the central mass, because the force is always attractive in nature. Two masses cannot repel. Two masses always attract. So the direction of intensity is always towards the center. Direction of intensity of gravitational field. But direction of intensity of electrostatic field can be towards center or can be away from the center. Okay. Next question. Now we'll solve a problem. Right, problem. Find the intensity of the electrostatic field at the point P. Intensity of the electrostatic field at the point P. So I have shown three charges. 1 microcoulomb. Do you know micro? 10 to the power minus 6. 1 microcoulomb, 2 microcoulomb, 3 microcoulomb. 1 meter, 1 meter, 1 meter, 1 meter. Find the intensity at this point. What is intensity? Force on plus 1 charge. So place, just imagine plus 1 charge. Imagine plus 1 charge. Okay? So you have to find the net force on this plus 1 charge. Can you find the net force on this plus 1 charge? Do you remember your mechanics, vector, resolution and all? Indicate the direction of force. Indicate the direction of force. This 1 microcoulomb will repel. This is F A. This is 2 microcoulomb. This is positive. This is also positive. So it will also repel. This is point B. This is AB. Then this is positive, this is also positive. So this will also repel. This point is C, this is FC. Okay, you have to find the intensity at the point P. Fa equal to 1 by 4 pi epsilon naught Q1 into Q2 by R square. 1 microcoulomb is Q1. What is the value of Q2? 1 coulomb, not 1 into 10 to the minus 6. 1 by 1 square. AB 1 by 4 pi epsilon naught. I have not told you about the value of 1 by 4 pi epsilon naught. Write in a box. It is 9 into 10 to the power 9. 1 by 4 pi epsilon naught in SI system 9 into 10 to the power 9. Memorize it. 1 by 4 pi epsilon naught equal to 9 into 10 to the power 9 into AB 2 into 10 to the power minus 6 into 1. What is the distance? Root 2. So root 2 whole square. FC 1 by 4 pi epsilon naught into 3 into 10 to the power minus 6 into 1 divided by 1 square. You have to find the resultant. How will you find? Always go for vector resolution. It is very simple. what he will do? He will resolve AB. AB cos 45 and AB sin 45. Then he will have one force in this direction, another in this direction, and he will apply root over p square plus q square. Solve AB into two components. Okay. So do not use the values now. Do not use the values now. It will make your job much bigger. So instead of that, first resolve. I am showing it here. This angle is 45 degree. So FA plus FB by root 2 FC plus FB by root 2. Is it okay? FA plus FB by root 2, FB cos 45 and FC plus FB sin 45. FB sin 45 is FB by root 2. Then what is the angle between these two? So what is the resultant? FR. Resultant will be this. This is the resultant. Find. This is FR. FR is actually the intensity. Root over FA plus FB by root 2 whole square plus FC plus FB by root 2 whole square. Now you put values and get the answer. So you will always find the resultant of more than two vectors using resolution. Using resolution, do not forget it. It is very vital. Because in each expression there is 1 by 4 parts. Right? So 1 by 4 parts, write it outside. Root over. This is how much? 10 to the power 6. 10 to the power 6 also. 10 to the power 6, 10 to the power minus 6. So 10 to the power minus 6 also can be written. Write 10 to the power minus 6. Then root over. Okay. So 1 by 4 pi epsilon written outside, 10 to the power minus 6 also written outside.
The resultant force equals to the intensity.
Resultant force equal to intensity. Why? Because you have assumed plus 1 charge here. The net force on plus 1 charge is the intensity. Okay. In this expression I have used Q1 into Q2. What I have written in place of Q2? 1. What I have written in place of Q2? 1. In this place also 1. That means the force, net force is the intensity because we have assumed plus 1. Okay. Next. Question. Question important for your board exam, right? Find the intensity of electric field due to a uniformly charged ring at an axial position due to a uniformly charged ring at an axial position. This is important for your board exam. This is a metallic ring. And this has charge on it. Total charge present on the metallic ring is Q. Radius of this is R. This is the axis of the ring This is the axis of the ring. P is a point. P is a point or A is a point at a distance of x. You have to find the field at this point. Calculation of field. Field means what? Force on class 1 charge. Calculation of field has become critical in this case. Why? What is the basic reason? This is because you have an extended charge distribution. Whenever there is extended charge distribution, calculus has to be used. The case is simple when you have point charge. A point. What is the field at this point? Simple situation. 1 by 4 pi square q by r square. But if this body is fully covered with charge, there is charge here, this charge will exert force in this direction, this charge will exert force in this direction, this will exert force in this direction, this will exert force in this direction. That is a troublesome situation. So we have to use calculus in all such cases. Okay, so remember, this is a case of extended charge distribution. That's why calculus has to be used. Okay. Assume class 1 charge here. Okay, consider an element, very small element, having dq amount of charge. Okay, its length is suppose dl. You have already placed a plus 1 charge here. So this dq, this is positive, this is also positive, this may be negative also in some other problems, but during derivation I am assuming this to be plus. So this will repel this force. Since the charge is small, the force is small, and this is dE dash. Since we have assumed plus 1, that's why I am using E. Now consider its counterpart. What is counterpart? Counterpart may be defined as the mirror image. Its mirror image is this. This is also dq. And its length is dl. Since this has exerted a force dE dash, this also exerts. dE dash force. Okay? This angle is suppose theta. So what is the net force? So first you write dE dash equal to field. See, field, electrostatic field and intensity of electrostatic field, they are synonymous, having same meaning. I may write intensity of electric field, you may write electric field, both are same. Okay, so I am writing, if you write intensity of field, that is correct. If I write field, then also it is correct. Okay, field and intensity, they are synonymous. So dE dash equal to field at A due to dq. Okay, dE or net field at A due to dq and its counterpart dE equal to how much? What is the net field? due to dq and its counterpart to d dash cos theta. Correct. Because this is theta, this angle is theta, this is theta. Resolve d dash. Resolve d dash. This is plus 1. There is a component in this direction. There is another component in this direction. Resolve this d dash. There is a component in this direction. There is another component in this direction. This is d dash sin theta. This is d dash sin theta. So d dash sin theta and d dash sin theta, they cancel each other, and this becomes 2d dash cos theta. So net field at A due to dq and its counterpart dE equal to 2d dash cos theta. Okay? Equal to, now write d dash field at A due to dq, right here. Field at A due to dq, 1 by 4 pi epsilon naught into dq into 1 divided by, what is the distance? Distance is root over r square plus x square. So root over r square plus x square whole square. Root over r square plus x square whole square. Put this. Have you understood this or not? Is it clear to all of you? Gunjan, have you understood this part? Samyukta, this is the field at this point. Field means intensity. Intensity at this point due to this charge. What is the formula? 1 by 4 pi epsilon naught into q1 into q2 by distance square. q1 into q2 by distance square. How much is q1? dq. You have dq amount of charge here. How much is q2? 1. You have plus 1 charge here. So dq into 1 divided by the distance square. What is the distance? Root over r square plus x square. So distance square means root over r square plus x square whole square. So put this into dq by r square plus x square into cos theta. Now replace dq. dq equal to a whole divide. What is the total charge? Q. What is the charge per unit length? Q by 2 pi r. Q is the total charge. What is the total length? 2 pi r. So what is the charge per unit length? Q by 2 pi r. So what is the charge present in dl length? Multiplied by dl. This is dq. Into cos theta. Right, cos theta will base x by hypotenuse equal to Is it okay? This is dE. In order to find E, I will have to integrate. I have not yet done the integration. I have written only dE. what is DE? The field at this point due to this charge, this dq and its counterpart. So what is the field at this point? What is the field at this point due to dq and its counterpart? Have you understood this much? Now write E. Hence, E equal to integration dE. E equal to integration dE. Can you identify the variable? Only dA is variable because for a given point x is constant. The point is fixed. That means the distance of the point is also fixed. So x is constant. The charge present on this q is also fixed. Radius of the ring fixed. So only variable is dl. Have all of you understood that x is constant? Because the point is fixed, that means its distance is also fixed. So integration dE equal to 2 by 4 pi epsilon naught qx by 2 pi r square plus x square whole to the power 3 by 2 integration dl. Integration dl or what is the limit of L? What is the limit of L? 0 to? 0 to pi r or 0 to 2 pi r? Pi r. Why is it pi r? Counterpart method. I am using counterpart. Counterpart means whenever you are considering this particular element, at the same time, are you considering this one or not? Whenever you are considering this, at the same time you are considering this. So if you just consider half of the ring, then automatically the other half will come into your or other half will be considered. Whenever you are considering this, at the same time you are considering its counterpart. So if you consider just half of the ring, automatically the other half will be taken care of. Have you got the thing? Have you understood the meaning? You are using this and this together. So just consider half. Automatically the other half will come in. ठीक है ना? So what will be the limit of dl? 0 to pi r, not to pi r. Okay? So 0 to pi r. Do not forget this. Okay? Whenever I use counterpart method, you will use in the limit you will use half only, half. Okay? So we have got a formula which is very, very important, both for your theory part, keeping in mind your board exam, and also for problem solving. Box it. Field at an axial point due to a charged ring. Field at an axial point due to a charged ring. What have you considered first? dq and its counterpart. Then what is the field due to dq? dE dash. What is the field due to dq and its counterpart? dE. How much is dE? 2 dE dash cos theta. Okay. Then what is the net field? Integration. 2 dE dash. the potential of an electrostatic field at a point. Potential at a point. Consider this point. This distance is r. P is the point, or A is the point. How do you define potential at this point? It is the work done. Who will do this work? External agent, not the electrostatic force. It is the work done by an external agent. That could be you also, that you have brought. It is the work done by an external agent to bring a unit positive charge from infinity to this point. How? Fast or slowly? Slowly. He will very slowly bring a unit positive charge from infinity to this point. The amount of work that the external agent will do in bringing this charge is the potential at this point. So write the potential at a point, of an electric field is defined as the work done by an external agent, in bringing a unit positive charge, slowly from infinity to the given point. So a class 1 charge, it will be brought from infinity to this point. This is infinity. Infinity to this point. In practice, a test charge is brought. So test charge, Q is the test charge. Work done to bring Q test charge to this point is W. So write W equal to work done by F external in bringing test charge Q from infinity to the point A. Then by definition, potential at A, V equal to, how do you find the potential? Work done to bring Q charge is W. Work done to bring one charge, Q. By definition, that is the potential. So V equal to, okay. So this is one important Formula V equal to W by Q. Potential is a scalar quantity. What is its unit? This is what is joule? Coulomb. So joule per coulomb. So potential, right? Potential is a scalar quantity. Is a scalar quantity. Its unit is joule per coulomb. Its unit is joule per coulomb. Okay, ठीक है. So what will be our next question? We'll find an expression for potential. What is the expression for potential? 1 by 4 pi epsilon naught into Q by R. Okay, so write next question. Prove that the potential at a point due to a charge Q, capital Q. Prove that the potential at a point due to a charge Q, capital Q, is 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught into Q by R. 1 by 4 pi epsilon naught into Q by R. So potential at A potential at A equal to W external by Q. Potential equal to W by Q. Who has done this what? Externalization. W. So I will now calculate W external. W external infinity to which point? Infinity to the point A equal to integration. Why integration? Because the force is variable. Okay, force is variable. In which, what is the direction of F external? What is the direction of F external? Towards Q. Why?
That is the push. Work done in bringing. We have to push the charge towards
this charge, the external force exerted by external agent, it could be towards this or it could be away from this. See, this is a positive charge. This is another positive charge. So what is this charge doing? This is repelling. So if you want to bring this charge, you will have to hold the charge like this. This is the charge. It is trying to fly away. So if you want to bring it, then you have to hold the charge in this way and you have to bring it. So in which direction are you exerting force? And what is that force called? You are exerting what? You are exerting normal force. You are exerting normal force. And this is F external. Okay, have you understood? If this is negative, suppose this charge is negative, then in which direction will you apply force? This is negative. Then this charge is this central charge. It is attracting that charge. Then you have to hold the charge like this. Because the charge is trying to go down. Charge is trying to move towards this. In order to bring, you have to place your palm in this position. So in which direction are you exerting the force? upward. You are actually exerting normal force. Okay. So when the charge is trying to fly away, you will place your palm like this and you are exerting in this direction. Force in this direction. You are preventing the charge from flying away. When the charge is being attracted, you will hold your palm in this position. You are preventing the charge from moving towards this. Then you are exerting normal force in this direction. Okay. So I'll show all these in drawing. This is Q. This is the direction of F external, and this force is F electrostatic. Okay, then this distance is x, this is x, suppose this is x and this is dx. I have shown both the forces. If you have any confusion, you tell. F external I have shown, F electrostatic I have shown. Electrostatic force is trying to repel that charge. F external is preventing this charge from going away. So this is the force that you have exerted. Simran Jalan. Not clear? Then why you are not telling? See, consider gravitational field. How do you define potential due to gravitational field? Work done to bring? Work done to bring unit mass. Unit mass from infinity to the given. So suppose this is unit mass. You are bringing it from infinity to the given point. So there is already a gravitational field, and this gravitational field has been produced by Earth. You are bringing this from infinity to this point. I am bringing it slowly. In which direction I have exerted force? What force I have exerted on this? Normal force. I have exerted normal force on this. What is the direction of this normal force? Normal force is obviously this, upward. So I have exerted force in upward direction. Is it okay? Is it okay? So I have exerted the force when I am bringing it from infinity to this position. I have exerted the force in upward direction. So this is F external. And what is F gravity? F gravity is downward. F external is upward. By definition, potential is the work done by gravitational force or the work done by external agent force. Work done by external agent force. Okay? So now in this case, the situation is different. The field is such that this is trying to go away. Suppose this is a large charge plus Q charge, and this is a small charge. This is positive. This is also positive. So if you release this, what will happen? It will move away. So in order to bring this, in which direction are you exerting force? Downward. Which force are you exerting? Normal force. Downward. So this charge is trying to fly away. So you are bringing it in this direction. So what is the force? You are bringing the charge in this direction. So you have exerted force in this direction, and this force is called the normal force. So that is F external, and this is F electrostatic. Okay, this is clear now. So F external dot F external dot dx equal to integration F external into dx. What is the angle between these two vectors? No, see the drawing. I have clearly shown it in the drawing. Why are you telling 180 degrees? What is the direction? This is f external, this is dx. The angle between the two is 0. Is it okay? F external in this direction, dx is in this direction, equal to integration f external into dx cos 0 equal to 1 equal to, this is w external equal to liquid f external equal to f external, can you write f external equal to f electrostatic? Can you write? Why not? That is in vector form. Magnitude wise are they equal or not? Magnitude wise f external equal to f electrostatic. Why? Slowly go through the definition. In the definition what I have told, the external agent brings the charge slowly. So when you are slowly bringing it, that means that means there is no acceleration. So that means f electrostatic and f external agent, they are always equal. Otherwise there would have been acceleration. And slowly means there is no acceleration. What is the meaning of slowly? No acceleration. No acceleration means f electrostatic is equal to f external. Okay, if f electrostatic is greater than f external, there will be outward acceleration. If f external is greater than f electrostatic, there will be inward acceleration. But you are bringing the charge slowly. Means the two forces are always equal. Okay, so f electrostatic into minus dx. In bracket you write, since charge is brought slowly, charge is moved slowly, hence f magnitude wise f electrostatic. And what is the cause of this minus sign? Dx, dt, dp, dv, dq, whatever comes with the final minus initial. dt, what does it mean? It means t final minus t initial. dp, what does it mean? Final pressure minus initial pressure. Now dx means x final minus x initial. What is the final position? You can see here, this is the final position and this is the initial position. This is the final position. So is the final value of x greater or is the initial value of x greater? We are measuring x from the center. Initial value of x is greater, final value of x is less. That means final minus initial is negative. dx means final minus initial. So write, since x final is less than x initial, hence dx equal to x final minus x initial, it is negative. Okay, so that negative sign I have used there, minus dx. Hence, now let us find hence W external infinity to A equal to minus integration F electrostatic into dx. Electrostatic force is known to you. How much is that? 1 by 4 pi epsilon q into q. What is the distance square? No, x. We'll put the limit of x. X square into dx equal to minus 1 by 4 pi epsilon naught q into q constant integration dx by x square. Now put the limit of x. What is the initial value of x? Initial value of x is infinity. What is the final value of x? R. R. Final value of x is r. This distance is r. This is r. This is r. Equal to. Now this is minus 1 by x equal to minus 1 by 4 pi epsilon naught q